Hi, this is EdApp, and what we're going to do today is learn how to use Tensorflow to recognize game pieces like these two from Rover Ruckus within FTC competitions. Now you might say, well, what gives? This year's game is called Ultimate Goal. Why are we learning how to recognize pieces from 2 years ago? Well, the reason is I'm going to show you how to do it. It's your job to then adapt these ideas to this year's competition or any other year's competition. Let's start out with a demo so we know what we're going to do. Okay, what we're going to do in Rover Ruckus is point our robot towards this gold mineral over here and then push it off of its starting point. So what are we going to have to do first? We're going to have to turn this robot so it faces the gold mineral and then have it go straight for a certain length of time. So let's see if we can do that. I push play. There it turned to the left a little bit too far and it turned back to the right, and now it's moving towards the gold mineral and pushing it off of the screen or off the field. And here's my favorite part. When the phone falls off of the robot, well, I think it's just a perfect demo or for a prototype robot, because the robot holds together for as long as it needs to. It demonstrated that the software I wrote works, and so I don't really care at that point if things kind of fall apart. So I think it's a perfect demo. Let's skip over some uninteresting boilerplate slides. For this tutorial, I'm going to assume that there are some things you know how to do. For example, I'm going to assume that you know how to write a Java program and load it into an FTC robot and get it to run. I'm also going to assume that there's some things about Java that you know. For example, I expect that you'll be able to write a program that will make the robot run forward until it reaches a line using a light sensor, for example. Now, if you don't know how to do these things, you can still take advantage of these tutorials. There are some things that you'll learn that will help you. So at any rate, good luck and let's have some fun. The rest of this tutorial is going to be broken down into 3 parts. The first part is we're going to take a look at how we can use machine learning to recognize things. So you can see here I'm recognizing myself, which is actually more difficult than it appears. Then after we've done that, we'll take a look at the code that is used to implement that. And finally, we'll take a look at how difficult recognition is. A convolutional neural network is broken into 3 parts. The first is the model. And the model is a file which describes how you can go about recognizing an object or how the software does that. The trainer is the part that creates this file, the model file, and the inference engine then is the software that uses that file to recognize an object given an image of that object. Then TensorFlow is simply a software framework that is used to program an application that can recognize an object. When we start autonomous mode in Rover Ruckus, the robot is within this blue rectangle, and then there are 3 objects ahead of it that it must recognize and then move towards the single gold one. The challenge is that we do not know in which of the 3 locations the gold mineral is. So there are basically 3 steps that we have to do. The first step over here is to recognize which object of the 3 is the gold mineral. Then once we have done that, we have recognized the gold mineral, we want to turn the robot so that it faces it. Once it faces it, we're going to move the robot straight ahead to the gold mineral and then push it off of its location. Let's get to the fun part and take a look at the code. We've all been looking forward to that. So the code is organized into 3 parts. The first 2 parts are going to deal with initialization, and we have to initialize and activate the camera, and we have to initialize and activate the TensorFlow object detector engine. So let's assume that we've done that and take a look at, once we've done that, the list of objects that have been detected. So let's start again with the fun stuff. Suppose my camera picks up this image of objects in the game scene. Now what we see here, or what the camera sees, is 1 gold mineral, 4 silver minerals, 2 chevron cars, and me. Now this is a little bit silly in that the Rover Ruckus game is not going to include chevron cars or myself, and more to the point is that even if these items are in the field, they will not be recognized because the model that we are using for Rover Ruckus can only recognize 2 pieces. It can only recognize gold mineral pieces and silver mineral pieces. And so if we look at the recognition that will occur, it will only recognize those 5 pieces. And within our code, when we ask for a list of updated recognitions, this list right over here, it is going to only have 5 items in that list, and we're going to call each one of those items a recognition. So let's see how that code works. One of the things I'm going to do is I'm going to start out with a TensorFlow object detector. That's where the TFOD part of this name comes from, and that is a object detector engine that I've created in a previous step, and we'll see how to do that in a minute. But I'm assuming here that I have that object detector, and I'm going to ask it a question. I'm going to ask it for some information, and the information that I want is for it to get an updated recognition. So I want to get that list. And so as we saw on the previous slide, there are going to be 5 items in that list if we get that image that we saw there. So I'm going to ask for a list, and I'm going to call it updated recognitions. This list is going to be composed of recognition. So there's going to be 5 recognitions in that list if everything works correctly. Then once I have that list, I'm going to want to go through that list item at a time, and in this case I'm going to do something very simple and print it out to the robot controller. So here's that list, here's that loop that I can use to go through that list. Within that for loop, we've mentioned that we're going to loop through all those recognitions, all 5 of them, and each time through the loop, we're going to call each one of those items in the list a recognition. So the first time through the loop, that recognition is going to be a silver mineral. And so when I come down over here, I have recognition again. And the thing that I'm going to ask for is recognition. Tell me what your label is. And the label on that first recognition is going to be silver mineral. And so then I'm going to add that to the telemetry information that I'm sending to the robot controller. So once I've gone through here 5 times, I will have executed that 5 times, once for each object in that list. I'm going to leave that for loop, and then I'm going to pause here for 10 seconds. And the reason I want to pause there for 10 seconds is it will give me time to read the items in that list, and it will tell me if the code is working correctly. So here is the driver station. You can see that the telemetry is being printed right here at the bottom of the screen, and the items that are going to appear in that list are these 5, with the first 3 being silver, the 4th being gold, and the final one being silver. Let's take a look at this code one more time. So what I said is each time we went through this loop, each of the 5 times we got a recognition. And that was one of the 5 items that we could recognize. And then we asked it a question to get its label. For example, again, gold mineral or silver mineral. Are there other questions that we can ask? Well, yes, there are. And so one of the questions we want to know is how confident is the Tensorflow object detector that it recognized something of interest. And so on this page over here, this screen that we can see being displayed from a phone or the monitor, we have this number over here. It says 0.957 03125. Pretty precise number. And so the question that we asked in order to get that response is, what is your confidence level? And when I say your confidence level, I'm talking about the Tensorflow object detector, that we actually detected a gold mineral. And it is telling us that it is 95.7% confident, really precise. So that's one question that we can ask. And there's others as well. Okay, we asked for the label. We can also ask for the top boundary. How far are you from the bottom of the screen? And the left boundary, right over here. So that's this question over here. How far are you from the left part of the screen? So those are some interesting questions. Let's take a look at confidence. We know that there was a problem with the Skystone challenge from the previous year. And that problem was that if you placed stones next to each other, like we have over here, it would recognize some of those stones, double stones, as a single stone. And here it sees a plain stone and then a Skystone, but the object detector is telling us that it is a single stone, and it's telling us it is that with an 88% confidence. It's not lying, it's just wrong. And so that is something that can occur. And what some teams did is they said, well, that's not acceptable for the model to do that. They retrained the model by taking, hundreds of photographs and then going through a process of retraining that took, a few hundred hours to create a better model that would distinguish between two stones when they were next to each other. But that was hard. And so that is something that we hope we don't have to do this year. So what kind of other situations can occur? Let's just take a look at some thought experiments of what can happen. So this is an example within the Rover Ruckus game is what happens if you have two gold minerals beside each other or two on top of each other. In this case, it recognized each one of those situations as a single gold mineral instead of a double. Is that a problem? Well, no, because that should not occur at the beginning of a game or any place else in the game when we're doing autonomous mode. Because there's only going to be one gold mineral that we have to deal with, and they're not going to be next to each other. So so this is not a problem with the model, but a problem with when we're going through and testing to see how it works. And there's other kind of situations that we could deal with too. What happens if there's a wicker basket in the field? Well, that's not going to happen. Or if there is a chevron car, well, that shouldn't happen either, and so we're really not worried about that. Okay, so I mentioned in the previous section that there are some things that we're going to have to do before we can start recognizing objects. And so we're going to take a look at how we go about starting object detection. So the things that we're going to have to do with telling the object detection what camera is supposed to be used, and then also tell the detector where to display the information so that we can take a look at it and see if it's detecting properly. We have a camera at the front and this monitor in the middle, and they are both connected, in this case, to the Compute Hub, which is a new device that is part of Rev support this year. In other cases, there can be an Android phone that encompasses all three of those items. We will start by setting up the camera, and we're going to use the Vuforia software stack to do that because it's already part of the FTC SDK for doing localizations, and so we're just going to use that code for another purpose, and that is for recognizing objects. The first thing we'll do is to create some parameters that will set the Vuforia software up. And so we're going to call those parameters. Here they are again and again. And so the first thing that we're going to have to do is to set the Vuforia license key. And there's a string that's associated with this uppercase label. And that is a key which I got from the Vuforia site, which gives me permission to use their software. And so that's one of the things we have to do is get permission. Don't use my key, please, because it's mine. And then, for the case of Android phones, we're going to have to tell it whether it uses the back phone or the front phone. Now, once we've done that, we want to create the Vuforia engine. And this is the engine that runs and is able to get the camera to work. So we're going to pass the creation of that, where we create Vuforia. We're going to send it the parameters that we created to get the camera going. The next part is to set up the object detection, or the object detector. One of those things we're going to tell it is where to display the images and the annotations that tell it about the objects that we've detected. And so that is the monitor view ID. And so that's going to become one of the parameters down here. And that parameter is going to be called TFOD parameters, or TensorFlow Object Detector parameters. That parameter is then used over here when we create the TensorFlow Object Detector. And another parameter is the Vuforia engine, which we created in the previous slide screen. Okay, so what this does is it creates the TensorFlow Object Detector. And we saw that in our first set of code, because we asked the TensorFlow Object Detector for a list of objects it can recognize. Now we're going to set some information in the TensorFlow Object Detector that's going to get us going. So one of the things that we're going to tell it is what model are we using. And the model that we're going to use is the one for rover Ruckus. And that model is good for recognizing silver minerals and gold minerals. And you'll notice that it's part of the assets directory, and it has a file extension of TF-LITE, which is TensorFlow Lite. And TensorFlow Lite is the version of TensorFlow that runs on small computers like Android phones and compute hubs. There are two other pieces of information that we want to tell it, and that is the label that we're going to use for the objects that it can recognize. There's only two objects, so we only have two labels over here, and the one label, label 0, is for the gold mineral, and the second label is the one for silver mineral. So that's what we're going to call them when we want to refer to them, or it will tell us that is the name of the mineral when we ask for the label. Now we could put anything we wanted to in there. We could call one zebra and the other one cow, but there's no really reason to do that. That's just going to confuse us. But it gives us a choice, and then what it really tells us is that the model really has no idea of what something that it recognizes does, or is, or represents. It can just associate a label of some sort with it. Okay, final step in our initialization is to take that TensorFlow Object Detector that we have created and activate it. And so what does that do? Let's go back to this screen over here. And what that does is it starts up the object detector. So it's going to show the gold mineral that it sees over here through its camera. It's going to show it on the monitor, and it's going to annotate it saying that it's a gold mineral, and then we can ask that gold mineral some questions. Let's do something a little bit more interesting than just listing out the names of the minerals that we detect. Let's determine if the single gold mineral is on the left side of the screen or on the right side. And we can use that to point the robot towards the gold. So the kinds of questions we're going to ask is, when we find the gold terminal, we want to know what its left position is on the screen and what its right position on the screen is. We can use those two values to determine where the center, then taking the halfway point of the display, which is 640, and suppose that the center of the gold mineral is at 300. We can take 300, we can subtract 640, and what we will do is we will get a minus 340. That number is negative, so the gold mineral is on the left side of the screen. So let's see how to do that with a code. Again, we're going to have our updated recognitions, which is the list, and then each of the recognitions within that list is going to be called a recognition. Let's start out here with this while loop. This while loop is something that you have seen in all your autonomous programs, and it is a loop that keeps on executing while the op mode is active, and that's for 30 seconds. Then what we're going to do is, while we're going through that loop many times, we're going to get a list of objects that it has recognized. We're going to compute the offset of the gold mineral, and then we're going to go through that whole process again. And so what we can do is we can move that gold mineral back and forth in front of the camera and see if it is indeed computing the offset appropriately. So here's where we get our updated recognitions like we have done before. We're just going to make sure that that list is not null, because bad things can happen. And so this is part of an important check that we should always do, is make sure that the list that we're looking at has values in it. And then once we have determined that, we can go through a loop and check each one of the gold or the minerals within that list and see if it is gold or silver. And if it is gold, like it is over here, then we're going to compute its offset. If it's silver, we're just going to ignore it. So we have the recognition. We know it's a gold one. And so we're going to get the left side of the gold mineral. And then we're going to get the right side. And then we can compute its center by summing the left and right side and taking the average, which is right over here. Now once we've computed that average and say that that average is 300, we can subtract the center of the screen, which we have decided is 640. And once we subtract that, we're going to get a value of a minus 340, I think. Okay, so what does that tell us? The negative value tells us that the gold mineral is going to be 340 pixels to the left of center. We've accomplished what we're going to do for this tutorial, and that is to determine whether the gold mineral is to the left, to the right, or dead center, and by how big the offset is. So let's just finish this up by doing a little bit of code cleanup, and I'll go through this relatively quickly. So this is the big picture of how the code looks. This is our class that we've created. It's compute turn. Execution begins here. And the first thing we're going to do within our execution block is to init Vuforia. Notice instead of putting the code there, I have a method call, and then we're going to init Tensorflow object detector. The two methods, two helper methods, are going to be right down here after the end of the run op mode is defined. Let's just take a quick look at what some of this looks like. This is the helper function for init Vuforia. You've seen this code before. I do want to make sure that you take a look at this error check. This is just checking to see that when the Vuforia engine was created right over here, that it actually did create it properly. And if it didn't, it's going to exit the program. Okay, there's a similar initialization for the Tensorflow object detector right over here. Here is its body, and it also has some checks in it, error checks, and these are important. This one checks to see whether the Tensorflow object detector has been created appropriately, and if it hasn't, it is going to again print an error message, but if it has, it can go ahead and activate it. There is another check up over here, and this is one that the FTC team has put in to make sure that the device that this is running on is capable to do Tensorflow object detection. And so if it is not capable of doing that, it's going to error out right over here. These checks are important because you want your robot to be in a known stable state before you push start, because you don't want it to fail immediately. At the end of the slide set, I also have some references for your benefit. They tell you, for example, where to find the code and the slides. They give you pointers or links to find references for the various classes that are used. And finally, there are some references for getting tutorials for Java if you want to brush up or you want to deepen your knowledge. This is EdApp saying goodbye. I hope you had a good time and that you can apply Tensorflow to your next project. Good luck and have fun.